Capacitor and application. Capacitor. A capacitor is an electric circuit consists of two metallic plates separated and insulated from each other by a dielectric element. Function of capacitors. It is used to store charge temporarily. One plate of a capacitor acts as the diaphragm. The vibrations produce changes in the distance between the plates. Types of capacitors. Fixed capacitors. Non-polarized. May be connected into circuit with either terminal of capacitor connected to the high voltage side of the circuit. Insulator, paper, mica, ceramic, polymer. Electrolytic. The negative terminal must always be at a lower voltage than the positive terminal. Plates or electrodes, aluminum, tantalum. Non-polarized. Difficult to make non-polarized capacitors that store a large amount of charge or operate at high voltages. Tolerance on capacitance values is very large. Plus 50%/25% is not unusual. Variable capacitors. Then, variable capacitor is the electrolytic capacitors. Cross-sectional area is changed as one set of plates are rotated with respect to the other. Ohm's capacitor can be a variable capacitor by changing the distance between electrodes. Used in sensing applications as well as in RF electronics. Electric double-layer capacitor, also known as a supercapacitor or ultracapacitor. Used in high-voltage/high current applications. Energy storage for alternate energy systems. Electrical properties of a capacitor acts like an open circuit at steady state when connected to a DC voltage or current source. Voltage on a capacitor must be continuous. There are no abrupt changes to the voltage, but there may be discontinuities in the current. An ideal capacitor does not dissipate energy. It takes power when storing energy and returns it when discharging. Properties of a real capacitor. A real capacitor does dissipate energy due leakage of charge through its insulator. This is modeled by putting a resistor in parallel with an ideal capacitor. Energy storage. Charge is stored on the plates of the capacitor. Equation. Q equals CV. Units. Farad equals Coulomb/capacitor in microphones. Condenser microphone are called capacitor microphones. In the condenser microphones, a capacitor has two plates with a voltage between them. One of these plates is made of very light material and acts as the diaphragm. It vibrates when struck by sound waves, changing the distance of the two plates and changing the capacitance. Specifically, when the plates are closer together, capacitance increases and a charge current occurs. How do condenser microphones work? The condenser microphone is made up of two plates, a front plate and a back plate. The front plate is known as a diaphragm and is made of a very light material. As acoustic energy hits the diaphragm, it vibrates, thus reducing and increasing the distance between the two plates. The coating vibrates sympathetically in response to a sound wave because it is very thin. The changes in the space between the surfaces create a changing discharge of electrical current. It makes an electrical version of acoustic energy from the sound source. Application of capacitors. Capacitor used as rechargeable batteries in many appliances. Uses as capacitive sensing in the touchscreen handphone. Capacitors used in automobile engine in the ignition system to eliminate sparking. Capacitors used in condenser microphone. Summary. Condenser microphones have a much greater frequency response other microphones. Can be used to record sounds from a greater distance and capture a broader range of frequencies.
I'm terrified of my intentions. I can see you.